Thank you, everyone that's here. It is a real pleasure to have you here at the Apex show, to have you at the booth. I've got some special guests with me. I'm Andrew Scheuermann, CEO and co-founder of Arch. I'll just let Jason introduce himself.
Jason Sparrow, CEO and co-founder of Aegis Software.
I'm Takeshi Sato, Fuji Corporation, head of SMT division.
Hi, I'm Daniel Brown. I work for Fuji Innovation Lab.
All right, so we have some world-class leaders from SMT equipment with Fuji here, and from MES, from Aegis with us. And we are talking about generative AI in the factory. And I think for some of you, maybe this term all the time, generative AI, we're talking about this new type of AI, the type I was just asking for a joke that powers ChatGPT. So beyond just what a lot of us already use in our factories, like to detect that temperature is getting too hot. You know, this new talking AI, how is it reinventing work for electronics manufacturing? That is our question today. All right, so it starts with the growing talent and workforce gap. In the US, we're here in California, there's 428,000 jobs that are open, and more than half, 65% of manufacturers say that attracting and retaining talent is the primary challenge. Not just one of them, like the primary challenge. And I remember, I don't know if my guests here, you do as well, but over the last few years, as we were starting to work on software, I would go to factories and I'd say, what's your top challenge? And they would say, it's just people. I can't keep the people that are going to the factory across the street. Well, I'm losing my expertise. And I said, man, I don't know if we have a solution to help with that. And it would frustrate me because I say, I want to help with your top challenge, but that's a people challenge. That's not a technology challenge. 3.8 million manufacturing jobs are needed by 2034. This is just the US number, much, much bigger when you go to the global. And if you ask, where is this coming from? Well, there's growth, there's legislative actions, and all the policy that's going on, but the biggest number by far is retirement. 2.8 million people retiring. So zoom out to worldwide, there's about 10 million factories, individual kind of building size plants that are in the world. They spend a lot on software, 100 billion, but that's nothing compared to the team, labor. It's the people that make the factory run. And again, you need experience. 5 to 10 plus years typically in an electronics factory. PCBA is complicated, right? You need to understand. And you know the type of people in the factory. They know the error code off the top of their head. Oh, 2201. I saw that one just last week. I know what to do. Oh, that's the same defect. I know what to do. My dad was one of these people. You just hear it buzzing and he's like, yeah, 2 weeks till that thing goes out. He just knew, right? 10 years ago in factories is 15 plus years was the average tenure. So this was fine. This was how we operated our plants. Now it's 5 years and dropping. People that are experienced are retiring, and the people that are coming in are often wanting to do another job pretty soon. It's a 300 billion expert labor crisis and growing. Every manufacturer has to do more with less. This is a quote from a particular manufacturer, Paul Baldessari, who has 100,000 people working for him at Flex. He says, each year we have to do roughly 10% more, but we have to do it with the same number of people. So, manufacturers have to do more everywhere with the same materials. They need to scrap less. So, if they're using the Fuji machines, how do we scrap less every single year? Right? They have to do 10% more with less expertise now. That's different than just the same number of machines, the same number of materials, the same amount of expertise, of brain power. How do you do that, right? That's a huge challenge. This is where this idea of AI-guided actions for the factory comes in. This is where these new generative AIs, like what's powering ChatGPT, this is where they really have a place in the factory. And that's what we're going to explore. So what we're going to do here is I'm going to ask Sato-san here a couple questions, and then we're going to show a use case of how we are doing this with Fuji machines and MES data in the factory. And then going to ask Jason here a couple of questions as well about their MES system. And we're going to talk about some of the big improvements in factory performance we've seen with coupling MES and AI. So Sato-san, I'll start with you. So the first question is, you have with the Fuji machines, the Nexum software the Fuji accessory software, and talk for a minute about the software that you've built, before AI. Like, how did you build it, and how is it meant to be used by the people, by the experts in the factory?
ネクシムやアクセサリーソフトについては、生産中に発生したデータを蓄積して、それを稼働率とか OEE の慣習に基づいて、吸着率であるとか、あとは生産効率の向上につなげるためのデータをレポートする機能を持っています。お客様はそのデータを使って独自のノウハウで生産効率の改善であるとか、現場の改善をやっております。
So a common issue that we see in the factory, and I was just in a Fuji factory last Friday, and they're using the software, but they don't always have the right expert or enough people or just enough time to look through all the different parts of the system. Can you talk a little bit from your perspective, any frustration, or how do you see this lack of time and expertise to use the software?
装置やアクセサリーから取れるデータっていうのは非常に限定的になっています。加えて、限定的とはいえども、データの量は莫大です。膨大な大きさあります。ですので、それらの莫大なデータの中から因果関係を見出して改善につなげる、そういったことは非常に多くの経験と高度なスキルを持った方に限定されます。そういったスキルを持った方っていうのは SMT の現場から少し減ってきているように思います。そこが問題だと思います。
So yeah, there's a lot of information, and there's some missing as well. What makes you excited about this new AI and the partnership that we have, and how AI can better bring value with your systems?
高度な経験値とスキルを持ったエンジニアが現場から少なくなっていることを補うためにも、AI によってその技術を補完して何をすべきかっていうのを明確にするようなソリューションが生まれることは非常に喜ばしいことだと思います。それからいろんな国に生産が行われますんで、各国に応じた翻訳であるとか言語に対応するといった UX の改善というのも大きく期待される部分であると思います。
Yeah, AI translation is a really powerful one, and supplementing with knowledge and reading the systems. So, okay, here is one of the screens from the Fuji accessory software. One of the many that you can look into. This particular one I can see has information about the nozzles that are having error codes. So as they're picking up parts, a specific nozzle, something that you can all do at home. And if you're not playing with ChatGPT, I hope that's one of the takeaways you'll have from this presentation, that you need to play with it. So it's, free app you can get on your phone if you're not chatting with it. It's so useful in so many ways. I'm going to use, this is consumer grade ChatGPT, the same one you get on your phone. So this isn't Arch's technology. And I'm going to pop it open, the same one that was telling us a joke. Okay, AI, I'm about to show you a Fuji dashboard here, and I want you to take a look. So I've opened the video on this, and I'm showing you live right now the dashboard. Can you see the top nozzle that's causing issues?
Yes, I see the dashboard. The top nozzle causing issues is H15214853 with 58 errors logged.
So it just used the live video stream to look at that dashboard and tell me the top one, right? I didn't tell it it's the one at the top. It's kind of obvious to us. We can see visually. You don't have to be like a deep expert to probably have figured that out, but you can see that it can think like us, right? That's powerful. So now the problem with just consumer grade ChatGPT is it can hallucinate, if you've heard this word. In fact, I don't know, I did that 5 times, and sometimes it didn't read the nozzle number exactly right. Or sometimes it could get a little bit off track. But you can see how close, how powerful it is. So what we are doing in collaboration with our partners, with Aegis and with Fuji, is, when we'll talk about this a bit more with Jason here in a second, is when we structure the data of the factory and we feed it to the AI systematically, we can guide the AI to give us a good answer. It's called putting it on rails. So there's this word AI agent that's really popular now, and the technical word is agent on rails. So instead of just ChatGPT, here's a giant pile of data I gathered from the factory, look through all of it, you do all the work, and please be 100% right. It's like, no, we're going to pull exactly the right information. We're going to give it to it in the right steps, and we're going to tell it to think the way a Fuji expert thinks about their tools. And when you do that, you're going to have to come up later and see this in more detail. But if you, by the way, we're writing a paper about this that we're about to release, and it compares actually 4 minds. We compare just consumer ChatGPT with this Arch optimized model, happens to be using Anthropic. But we also compare experts themselves. Folks, Gotti has signed up some experts to do this exercise, and I signed up a bunch of smart PhDs that I know, but they know nothing about SMT to compete with ChatGPT. So it's a funny paper. I hope you'll read it. But we have these 4 sets of brains, right? All smart, but some with no knowledge of SMT. That's what ChatGPT is. We give it those Fuji screens and we say, tell us what to do. You can read it later. It's close to correct. It's very impressive, actually. But when it says, hey, what should you do next? It says, inspect and calibrate the feeders, plural, and nozzles related to the top error. It's a little bit obvious, right? Follow the top error and look at all the feeders and all the nozzles. You don't actually want the people in the factory checking tens of feeders and tens of nozzles, right? But it's in the right direction. So it's very impressive, but it's like 5 out of 10. Now, here is the result when you take that data systematically, you combine the expertise that operators of Fuji machines really have with, again, this agent on rails philosophy, and you get the issue is error code exactly this. You saw AI could pull that out on exactly this feeder at this location. This is the name of the error code. What do you do about it? Not recalibrate every nozzle and every feeder. Inspect and adjust exactly this feeder. If that's not there, verify the part presentation at M243. So it is precise, it's specific, and to the root cause. It identifies exactly what's going on. So our expert panel in the paper rated this currently at 9.5 out of 10. And because experts are very good at figuring out as a factory, but they're actually not as good at AI already at clearly writing guidance to others. Partially they get tired of doing it. Maybe they speak other languages. And so in the paper, again, I encourage you to read it. This AI system is similar to or more effective than 20-plus-year experts today, 50 times faster, and more than 100 times cheaper. 50 times faster, more than 100 times cheaper on a technology cost versus a salary cost to give this guidance. Now, the first thing some people think is, oh my gosh, is AI coming to take the jobs? I don't know if I like this. I was just talking about this with a lot of folks earlier. We have a choice of where we use AI. We want to use AI to get rid of the dull, dirty, dangerous, and disappearing jobs and leave us the good ones. And that's what we try to do at Arch. So this work of digging through reports and dashboards to write a very clear next steps for a junior engineer, that's dull and disappearing. It's not fun. Your experts want to be doing other things, and it's disappearing because they're retiring. So we think this is a fantastic use of AI that we see our customers really adopting, and it's working now. Okay, so this is an example of an AI-guided action in the factory that works today 50 times faster, 100 times cheaper than these disappearing experts who need to be doing other things. So what you didn't get to see was all the work that goes on behind the scenes to make that good result versus just the ChatGPT result. And that's the reason I wanted Jason to come here from Aegis, because a big key of this is structuring the data. So again, we can feed the AI just the right pieces with logical connections. So Jason, to start, go back before AI again. And you guys have built a sophisticated and good model before this AI existed. Why did you do that, and what was the purpose of that?
Well, Taki, it's interesting because Sato-san touched on there is the machines know a great deal, but the scope of what they know is maybe not as great as people think. So depicted here, we have at the bottom the machine data. And when we founded the company, we thought from the beginning that the most important thing we could do was to have a large, meaningful, structured data model. Everything else was secondary to that goal. And at the bottom was the machine data. And we did that since 2000. from 1997, we had the CAD model. It's actually the core of the entire data model. And then above that is an oft-forgotten element, which is the human in the factory. We still have them, or will have them, and they produce data through their actions in production. And then that's added with the business system information. When you combine all of that, the data becomes very powerful for use in other systems. Now, originally, the reason we did it was analytics, basic analytics, and actually running execution of the shop floor. We felt required all of that. The meaningful links of all that data drive the execution. But what's interesting now is with AI and what Arch is doing, it's one of those kind of fortunate situations where with the emergence of AI, Arch is able to leverage that holistic data that's structured and doesn't have to be retagged or reprocessed into labels in a way that then can be used in more powerful applications, as we just saw.
Yeah, I'll just double on that point. It's funny that there's an old AI and a new AI already, but the old AI, which is often called classical AI, is like take sensor data and predict that the temperature is getting too hot. And that needs your data really well structured. You know, if you had an Excel spreadsheet, it's have the name of the temperature and the timestamp and everything super even. But this new AI, the thinking, talking AI, works like a human. And so if your data model is structured really well for expert humans, it is also structured well for AI. So you just explained that, which was great. And that's one of the reasons we've been so excited about the partnership, is we recognize we like you all as people very much. And we also recognize that your data model had this lucky or sage prediction of it should be structured. Talking your view, Jason, about this lack of experts, do you see this in your deployments where factories could get a lot more out of your software if they had more people with more time? And when does that come up?
It is actually, honestly, one of our corporate disappointments is that we generate a great deal of data and we can make it available to the operators and dashboards and so forth, but it's the bottleneck is the availability of the experts. And it's not really a skill issue, it's just time availability and their resources to actually gain insight from the data. So it's always been frustrating to us that we knew how much could be done with the data, but pre-AI and pre our work with Arch, it wasn't necessarily possible. And so that's what's really exciting about the partnership. And also, to extend what you were saying, it is interesting when our companies started working together, our technical teams found that the way we modeled and looked at data was almost identical. And so the integration was really quite easy.
Yeah, that's right. That was a striking realization that for two different purposes. So I wanted to bring up a financial impact example because it's critical. We all get, okay, this AI should be able to help improve the real KPIs, but it does. It is directly relevant to the downtimes, the deviations, to quality, and to delivery, making use, overall utilization, your scheduled time, your unplanned downtime. And as Jason, as you said, you shared, one of your disappointments is that there's a lot of the things factories need to do are in fact there in your tool. And you have the data, you have the reports, and this can be often true in the Fuji dashboards as well. But the factory simply has run out of time to use them. And back to the retiring experts, it's getting worse, not easier. And so it's getting harder to spend time using these reports. And so what's happened, this is a factory in China. This one was doing electronics, SMT for automotive application. It's a very good factory. And I picked a Chinese example on purpose because a lot of people think this is purely an American phenomenon, that we're having people retire. We're the only country struggling with this. That's not the case, right? This is happening, in fact, all over the world. It's extremely acute here in the US, but it's even true in China and in other places around the world too. This is a factory in China. And they have an MES system. They've got a good system in place. They have tools to detect downtimes, but they've used it as much as they can till they got to get back to their day. What we've implemented over the time range, especially after the shaded blue area, so we were setting up in this period, and after this period, we've introduced these AI tools that are helping them label the downtime. So what's the cause of my downtime? Is it machine? Is it a method? 4Ms plus E's. Classic idea, but with less labor. They don't have to have their people do every single part of the labeling. which of course results in them often skipping it because they don't have time. And then at the end of the day, the end of the week, they look at the report and it's half empty. We didn't get really a chance to label it. How should we improve? I don't know, right? When you have an AI system, in the moment, it can be labeled with root cause. So I fix it immediately faster. And at the end of the week, everything was labeled for me. So I can just get straight to looking into the root cause using the specific reports and data that are there in the structured MES and in the machines to make progress because they were read for me in real time. And you see in this particular case, we got down 2 hours per line per week from 4.2 to 2.2 hours. And this was worth $1.1 million in this factory. The other thing that's not shown on this slide that we measure is, back to this example with Fuji, message we call a guided action at Arch. So somebody should take action on this. They should go and inspect and adjust the feeder. Or in the case together with ARIA system, how do you solve the downtime? How do you solve the quality issue? Or possibly machine data through Aegis as well, similar use case. These are a guided action. And we can also measure exactly how many actions the factory is completing. So we actually do know the difference. If a factory just got lucky and their KPIs are improving, but they didn't actually use our AI, we see that and we discount those. So this factory example that I'm giving you is completing about 15 actions per line per week. They're completing them successfully with the guidance, and we're seeing a strong correlation. And not showed here, we don't like it, but we've seen it, that factory, stopped using guidance, and we've seen the back up. So we know it is highly correlated to their ability to do it. We know that data, we know it from being in person with them, and the savings can be significant. Would either of you like to make any closing statement to everyone or just welcome them to your booths and to learn more?
Thank you very much, Andrew and Arch, and appreciated adding our opinions and the partnership we have with the company. And yes, please visit the Aegis booth if you want to learn more.
Thank you, Jason. We've got Deb's email here and their booth. And Sato-san, Daniel, would you like to say anything in closing?
AI を使うことで SMT の現場がもっと良くなること、すごくワクワクしています。富士のブースにぜひお越しください。いろんなソリューションが見れると思います。
Right, and if any of you would like to stay here now, we will at the two monitors. We can take a few questions, sure. I was going to say we can show you, in addition to the example you saw here with Fuji, we can show you some of the automated downtime labeling as well, if you want to see it live. Yeah, sure. Are there any questions? Anyone would like to ask? Okay. I knew you were going to do it, David.
All right. For the team, if you look at process control, you got, proportional, integral, derivative. I see proportional and I see integral there. How are you going to predict the next nozzle that's going to fail?
Great point. PID controller, proportional integrated derivative. So his question, I think you heard it, was this is AI prescriptive analytics. It's telling you exactly how to fix it, but the problem has already happened. It's reactive to the problem, and then a prescriptive fix it. So when can you predict it? So we predict as well. Our goal is absolutely to predict. Well, I think before generative AI, that was the singular goal of everyone. Can we predict every single failure and just they never happen again? And that is a goal still. But this technology came out of left field with generative AI. Wow, it is so powerful. And in a way, it doesn't change the game on the predictive part, but it jumps you to prescriptive, right? So to answer your question first, the indirect answer is this is the thing that is new and powerful and did not exist even a year ago, right? But to your question about predictive, for example, in our collaboration with Fuji, we have a model that is looking at the attrition over hundreds and thousands of machines, and we are doing the machine learning ourselves to better predict, as you said, when is the nozzle going to fire. So we use a different method to do it, but we do both. So at the end of the day, hopefully they come together, right? Like we predict that the nozzle is going to fail, and this works exactly the same. So we could have, instead of it's already failed, we dig through and we tell you how to fix it, we predict it's going to fail, we dig through the reports and dashboards and tell you how to fix it before it fails. So this is the prescriptive part, and it builds directly on top of a good predictive alert as well.
The same way that we are looking at nozzle and errors and downtime in quality, we are following up error codes from different machine types. Error codes in combination to error codes, and SME will tell you when the machine will break down. If you are monitored with a specific prompt, that's a predict.
We had a question, Corey?
My question is this integration also continue to the feeder? We tell the operator that the feeder is going to run out soon so they can switch it.
Yes, yeah. Can this type of solution go all the way to the feeder? It can, yes. So it can absolutely go to the feeder, tell you if you're running out of a material. In fact, what you're saying, think about the way that we did this method. The way that we did this was we both used data out of the database. You don't really see it, but it looks like an Excel spreadsheet. And we literally used a picture of this dashboard. This is extremely exciting for smaller manufacturers, not just big ones, because the big manufacturers typically have sophisticated integrations to their global system. So we could get materials running out from a system, maybe they have towers and they have all the levels of the different components. But let's say you don't have that, but you do have some kind of system that's also tracking material levels. You could add that into the AI so it can look at that too, right? So it says, yeah, this specific feeder is running out of parts, and I can see that that's a problem. So yes. Maybe we have time for one more. No question is a bad one. Don't hesitate. I'll give one chance. Anybody else want to?
Slide you on a second, please.
What about the fallout rates? You losing a component through this component placement.
Yeah.
Does that calculate that into the issues?
Yeah. Talk about fallout rates.
So components fall out of the feeder, that's attrition. That's a scrap that you need to discount. So from that part, we are counting on those, even that they are falling in combination. But this is part of the rate that we are monitoring from that point of view. And by the way, these generated by a specific error code that we are also following now.
All right. So I will close by saying this. The first takeaway was, if you haven't played with ChatGPT, make sure you do it and go back to your factory, your company, and take a picture of one of the dashboards there, or tell it about it and prove it to yourself that it thinks like you do. The second takeaway was that the systems that you've invested in, if you have Fuji machines, if you have Aegis as MES, you've often been saying, I think I have the data already. I just need it to be used better. Everybody says that. That is now more true than ever before. It's been true, but it has been hard to use it correctly. So we all thank you when you give us a break in the past. But it is more true than ever that we can use it better. And so think about the systems that you already have. Do you have an MES that structures data correctly? Do you have machine systems that provide this knowledge to you? And if so, you're in fact in exactly the right place to start using AI in your factory. Thank you all so much. Thank you for coming. Thank you, guests.